Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about definition of covariance, definition of skew, definition of kurtosis. First we are going to define definition of covariance. If capital X and capital Y are two random variables, then the covariance between two random variables x and y is denoted as covariance of x comma y, and it is given by or defined as covariance of x comma y is equal expectation of x minus e of x into y minus e of y. Expectation of x minus e of x into y minus e of y, where expectation of x is the expected value of the random variable, that is first moment of the random variable. Expectation of y is the expected value of the random variable y, that is first moment of the random variable y. So now here this within the bracket term multiplying x minus e of x into y minus e of y, we get four terms that are expectation of xy minus xey minus e of xy minus into minus plus e of xey. Multiplying these two terms, we get four terms that are shown here. So using property of the expectation, that property is expected value of sum of random variables is equal to sum of their individual expectation. So using that property, the RHS term is applying the expectation into each term. Expectation of xy minus expectation of x into expectation of y minus expectation of y into expectation of x plus expectation of x expectation of y. So now here minus expectation of x expectation of y plus expectation of x expectation of y is cancelled. We get the remaining term is covariance of x comma y is equal expectation of xy minus expectation of x expectation of y. So this is the definition and derivation of the covariance of the random variables. So this definition and this expression is very important. Keep in mind. Capital X and capital Y are the two independent random variable. Expectation of xy is equal to expectation of x into expectation of y. So the condition of the independent random variable, expectation of xy is equal to expectation of x into expectation of y. Applying independent random variable condition on RHS side of this equation, the covariance of x comma y is equal to 0. If covariance of x comma y is equal to 0 mean the random variables x and y are said to be uncorrelated random variables. So this is the definition and derivation of the covariance. Next, we are going to define skew. And what is the skew? The skew of the density function is a measure of the asymmetry of the probability density function of a random variable capital X about x is equal to m1. If a density function is symmetric about x is equal to m1, then it has a zero skew. Once again, if a density function is symmetric about x is equal to m1, then it has a zero skew. The skew of a density function is also called as thought central moment of the random variable, and it is given by m3 is equal expectation of x minus m whole cube. So this is the thought central moment. The normalized central moment, that is m3 divided by sigma x cube. M3 is the third central moment, and the third central moment is expectation of x minus m whole cube divided by sigma x cube is known as the skewness of the density function or coefficient of skewness. So this is the definition of the skew and definition of the coefficient of the skewness. Next, I am going to define kurtosis definition. So kurtosis is a measure of weakness of the probability density function. A distribution may have its values centered closer to the mean so that the distribution has a large peak. The degree of weakness of a distribution is measured by using coefficient of kurtosis, and it is given by or given as expectation of x minus m whole to the power of 4 divided by sigma x power 4. So expectation of x minus m power 4 is the fourth central moment. This is the definition of the kurtosis. So kurtosis is a dimensionless quantity.